In part 2 of annuities, we're looking at a different formula. So not looking for future value. In this case, we're looking for present value. So this can be a little bit of a confusing concept just because of the name. Present value, you might think, oh, well, I look at my annuity and see what's the present value of my account. So it's not necessarily looking at it that way. So let's see what we're talking about here. So we have this idea that the accumulated amount, so the future value, from the compounding section, so this was from 5.1, we had this formula, okay? And then in the next section that we just talked about, we had this new formula for future value, which is taking payments. And those were compounded, each compounding period. So this is an accumulated amount with a lump sum, and then this is an accumulated amount with payments. So they're both accumulated amounts, and so we're going to set these two things equal to each other. So if we take P times 1 plus I to the n is equal to R times 1 plus I to the n minus 1 over I. Okay, so remember this is the accumulated value for the lump sum investment, and this is the accumulated value for the payments that are invested. And let's solve for P. Well, if I solve for P, that means I need to get rid of this factor right here of 1 plus I to the n. So I could divide both sides, since it's multiplied, by 1 plus I to the n, which means I'm essentially multiplying by the reciprocal. So let's multiply both sides by 1 over 1 plus I to the n. Now, when I show you something like this with the formula derivation, you don't have to be able to reproduce this, but my goal in showing you this is hoping to help you understand what present value actually really means when you look at this formula, so that you don't struggle with the concept so much. So when we do this over here, we end up with just P, which is the present value. That's like that principal amount that was invested, like the lump sum principal amount invested, okay? Then we get an expression that relates that lump sum to the payments. And so this lump sum related to the payments, they both kind of have that same accumulated value because they were set equal to each other. So it relates those two ideas of that accumulated sum and that payment. So here we've got R on the outside, and we can put this 1 plus I to the n down in the bottom with this I. And remember, this is really two fractions right here, right? Because it's like that mucus problem in Math 119. So you can break it up right there. So you'd have 1 plus I to the n. If we do break it up and bring that into the denominator on each fraction, then over here, it's going to cancel on that fraction. So it would leave me with just a 1 on the top. And over here, I could think about bringing that up to the top with a negative exponent, because then I would have just I in the denominator of both of those fractions, and it would allow me to write it with a single denominator. So I've got 1 up here from where they canceled, and now I'm bringing this up to the top with a negative power. Make sure you get that negative in there. It's really, really important. Then I've got a common denominator of I. So the present value is R times 1 minus 1 plus I to the negative n over I. So the variables stand for P is that present value. You can also think about it as that principal lump sum amount that would have to be deposited. So this is the PV. N is the number of payments. Number of payments. And I didn't write this on the last formula, but you can put it in there. It is still equal to MT. Same thing on the last one. R is the amount of each payment, and I is equal to R over M. Same thing as before, the interest rate per period. And we're assuming here that the future value on this is equal to 0. So these problems are not as easy to identify. The last one with you're trying to see how much you're going to have at the end when you save everything up. So it's not as easy to identify. So some things to look for in your problem. What is the cash price today? Okay, so that's a present value type of problem. How much would you need to deposit today to be able to withdraw X dollars per month at a later date? Or it could be simply just straightforward, and it'll just say, find the present value. Let's look at the first example here for present value. So in example 3, very straightforward problem. Find the present value of the ordinary annuity. Round your answer to the nearest cent. So we've got $2,000, semi-annual period for 9 years at a 5% year compounded semi-annually. So we can plug everything in and just go about our business. So P is equal to, again, you would be given this formula on the formula sheet, but it would not be within the problem. And the way I know to use it is it's asking me to find the present value. And I'm making payments here. So we've got 2,000, and then 1 minus, 1 plus. Remember, I is that R over M. I is equal to R, which is 0.05, over M. Now for semi-annual, M is equal to twice a year. M is equal to 2. So 0.05 over 2. Don't forget that negative sign right there. I've missed that so many times, and my calculator's giving me errors every single time. All right, so you need M times T. So 2 is M, semi-annual, and then the number of years is 9. And this is all over R over M. So 0.05 over 2. Again, sometimes easier to work backwards on the parentheses. 0.05 divided by 2. Need that denominator all in parentheses, especially since it's a fraction. Okay, and then we've got the whole numerator. Needs to be in parentheses. And then we've got our 2,000 out front. So whole numerator in parentheses, but I've also got this stuff that needs to be in parentheses. And within that stuff, I've got a fraction which needs to be in parentheses. And then I need to raise it, and I'm going to go ahead and multiply that out so I don't have to have more parentheses here, to the negative 18. Make sure you get that minus sign in there. So let's check it out. Make sure we got all our parentheses that we need. So here's the numerator. Here's what is raised to that power. This is for the fraction inside that, and this is for the denominator. And again, we could put that extra one here for 2,000 times everything, but I don't necessarily think that that one is absolutely necessary. So to get out of this, by the way, you have to do second mode to quit. Let's type this in. We've got 2,000, and then 1 minus, 1 plus. Make sure you get all your parentheses in there. Close, close before you do the caret. Negative sign, not the subtraction sign. All right, double check your calculator entry. We should be getting 28,706.73. So P is equal to 28,706.73. The great thing about the formulas is you don't have to worry about, what do I have to plug in as a negative number and what has to be plugged in as a positive number, right? You just have to figure out what formula works, okay? But over here on the TVM solver, you got to know what's positive and you got to know what's negative. So if you're making payments into something, that means money's going away from you, then it's going to be a negative amount. When we see that we're putting in $2,000, that payment amount needs to be negative right there. So minus $2,000. Our number of payments, we've got semi-annual, and then we're doing that for 9 years. So if you want to type in 18, that's fine. And then interest rate is 5%. Present value is what we're trying to find, so just put a question mark right there. Future value is always going to be 0 here. And semi-annual is the payments per year, so that's going to be 2. Compounding is the same. And remember, alpha enter is what you hit next on the 0 where you want to figure out what it is. So go to the APPS button, hit enter on finance, enter on TVM solver, and start typing stuff in. This time it's present value that I want to find the value of. So that's where I'm going to put my cursor. And alpha, the button under the second, enter. And you'll notice we do get 28706 and 73. So we're going to get the same thing as we did before. Example 4, you made a down payment of $5,000 toward the purchase of a new car. To pay the remaining balance of the purchase price, you secured a loan from your bank at the rate of 5% per year, compounded monthly. Under the terms of your agreement, you are required to make payments of $440 per month for 36 months. What is the cash price of the car? So remember those few examples I gave you underneath that present value formula? What is the price of the car today? P is equal to, we've got our payment amount of $440. Again, this formula would not be given. You'd have to be able to choose that off the formula sheet. That's how you know it's present value. So let's put a note next to it. We've got 1 minus, 1 plus. We've got to choose our R over M from the paragraph. So it looks like we've got 0.05 over 12. 5% compounded monthly. And it's very important to have that negative sign up there. N is equal to MT. So monthly for 36 months. Well, wait a minute. They've already given me MT, right? Because monthly 36 months is 3 years. So 12 times 3 is 36. So you got to be careful reading that. And then I is equal to R over M. Remember, T is in years, right? So MT is the total months, and it already gives me the total months. Again, if you need to work backwards with parentheses, by all means do it. Whatever helps you. So denominator all in parentheses, numerator all in parentheses, and then start going with your numerator. And then all this stuff to the power has to be in parentheses. And then the fractions within that stuff have to be in parentheses. So second mode to quit. And we actually already have kind of the setup of everything. So let's just do a second enter. And let's just change some stuff around. So I'm going to change that to 440 and just delete that extra 0. And 1 minus, 1 plus 0.05. I'm going to turn that 2 into a 1, but don't hit 2 because you have to insert. So second delete 2 to get the 12. And negative 18 is 36, so just type over. And 1, 2 parentheses. So that should change it for you. We're down to 14, 680, 91. Now be careful. It asked for what? The cash price of the car. And what did it tell us in the first sentence? You made a down payment of $5,000 toward the purchase of a new car. So we're going to have to say 14,680.91 plus our down payment was $5,000. 19,680. 91. That was the total cash price of the car. Let's see what we have to do with the TVM solver. So go to Apps, Finance, type TVM solver. So up here, total months is 36, number of payments. The percentage is 5%. Remember, don't convert over to decimal. Present value is what we're looking for. Payment amount is negative because we're paying it in. It's $440. And then future value, we have to pay the car off, so that'll be 0. Payments per year, paying monthly, so 12 and 12. So type that on in. You can just put 0 on the one that you're looking for and then go back and put the cursor on top. Alpha, enter to get the value. So that's what's going to return 14,680.91. So after you got that answer, that's when you would then have to add the $5,000 down payment.